everyone. We'll present Snowflake Arctic and talk about how it empowers efficient, customizable, and secure enterprise AI. This work has been done by our great Snowflake AI research team. I'm Yuxiong. Today, my colleague Samyam, Rajbhandari, and I will jointly present this session. As we dive into the world of AI, the first question we ask is, what our valued customers truly seek for their enterprise AI solutions? We summarize the main expectations and requirements in 3 areas. First, powerful and cost-effective enterprise intelligence. Our users need powerful capabilities on writing sophisticated SQL and codes, following complex instructions. In addition, they need these powerful enterprise capabilities to be done in cost-effective manner. Second, customized excellence. Each enterprise and each use cases can face their different challenges. AI needs to be tailored and specialized for customer use cases and domains. Thirdly, trust and secure. Trust in AI is just so crucial that in many cases that we do want to protect our customer security and isolating enterprise IPs. So this important need of our customers have been the driving force behind the Snowflake Arctic project. This need has shaped our mission and guided our investment. At Arctic, our mission is to deliver efficient, customizable, and secure enterprise intelligence for our customers. To achieve our mission, we have made substantial investment in innovation and engineering. These investments are structured around 3 key areas. First, we are dedicated in building innovative foundation models for top-tier enterprise intelligence at low cost. Second, by recognizing the diverse need of our users, we are creating AI that powers customer-specific use case and domains. Third, treating security as a cornerstone while building enterprise-grade AI solutions that are secure and trustable. With this foundation laid, we will now dive deeper into each of these 3 investment areas. First, let's look at innovations in efficiently intelligent foundation models. Arctic family has released 3 categories of models. Arctic Embed for enterprise search, Arctic LLM as large language model, and Arctic Tilt for visual text understanding. All 3 of them have a common thing of being efficiently intelligent, achieving more with less. I would love to give an overview for all of them if I could, but with limited time, let's dive right into the focus of today's talk, Arctic LLM. For simplicity, we'll just refer to it as Arctic for the rest of the talk. Snowflake Arctic has been launched in April this year. It has 3 unique differentiators. First, top-tier enterprise intelligence. Second, breakthrough efficiency. And third, truly open. The third differentiator, truly open, refers to our open approach of not only including weights and code, but also open data recipe and research insights. This has profound implication on the trustability of AI, which we will talk about at the last section of the talk. In the upcoming slide, we will dive into the first 2 differentiators, enterprise intelligence and breakthrough efficiency. Let's start from enterprise intelligence, and we'll share our understanding on what core capability it includes. At Snowflake, we see a consistent pattern in AI needs and use cases from our enterprise customers. They want to leverage LM to build tools like Conversation SQL Data Copilot, Code Assistants, and RAG data pods. The capability of building these cases are translated into 3 core capabilities that LM needs to excel: writing sophisticated SQL, generating accurate code, and following complex instructions. Then, each of these capabilities can be assessed and measured by their corresponding benchmark and matrices. For example, for coding capability, we can use MBPP plus and human eval plus to evaluate it. Then altogether, we try to capture this capability into a single metric, which we call enterprise intelligence, which is calculated as an average score across 3 areas of benchmarks. Now we know what's enterprise intelligence. Let's look at our key result. This slide shows a key result of Arctic. Arctic achieved top-tier enterprise intelligence and breakthrough efficiency. These are its top 2 differentiators. To see this more closely, let's check out the figure. The figure has 2 dimensions, showing the performance and cost of LM. On the x-axis, we see training cost. The lower, the better. On the y-axis, we see enterprise intelligence. The higher, the better. The blue region is the most desirable area we want our models to be, with high performance and with low cost. Clearly, we can see Arctic is a leader over there. Arctic offers the best enterprise intelligence with only a fraction of training cost. Comparing with Llama 3 8B and Cold Llama 70B, it consumes only half of the training compute while achieving significantly better performance. Comparing with DBRX, it only requires 1/7 of the training compute while getting better performance. Comparing with Llama 3 70B, it achieves similar performance on enterprise intelligence while only using 1/17 of the training compute. From here, we can see that Arctic is a leader on offering efficient enterprise intelligence. It also means Snowflake users can leverage Arctic technology to train customized models in much more affordable way. We have talked about training. Now let's move to inference. On inference, active parameters are a crucial factor determining the amount of compute need, which impacts throughput and latency. Active parameters refers to the actual parameters during inference for a given input. So Arctic has 17 billion active parameters. Comparing with Llama 3 70B, it only incurs 1/4 of the inference compute cost. This once again demonstrates that Arctic achieved great performance cost ratio even for inference. Overall, Arctic delivers top-tier performance on enterprise intelligence at a fraction of cost on training and inference, aligning perfectly with the need of enterprise customers. By now, you may wonder how we achieve top-tier intelligence and breakthrough efficiency together. This comes from our insights and innovations of 3 main areas. First is model architecture innovations. We created MOE-dense hybrid model architecture that allows the model to have big capacity while only using moderate compute. It's very friendly to head communication and promote system scaling. Second, dynamic data curriculum. Our dynamic and multi-phase training goes from basic and generic concepts to more complex and specialized concepts. It's very similar to how human learns. Super effective with respect to data efficiency. Third, efficient training system. Here we build hardcore system technology to optimize communication and boost compute efficiency, which empowers the scaling towards thousands of GPUs. So to the best of our knowledge, this is the fastest system for training MOE models. So far, we have explored our first focus area, building efficiently intelligent foundational models. Now, my colleague Samyam will talk about how we leverage and tailor these powerful models to meet specific enterprise needs. Over to Samyam.
Thank you, Yuxiong. Hello, everyone. Okay, so enterprise AI can take many forms, from powerful search experiences to domain-specific copilots. And while all of these scenarios require LLM that have very strong enterprise intelligence, that alone is not sufficient. The full set of capabilities required to excel at these domains can be diverse and varied. Let's take a few examples. Cortex Search provides a powerful search experience using retrieval augmented generation. To be really good at Cortex Search, the LLM powering it must have good RAG capabilities. On the other hand, Snowflake Data Copilot allows users to use natural language to produce SQL text. Doing well at this task requires the LLM to not just be able to follow complex instructions, but also have very good text-to-SQL capabilities. Similarly, there are many other domains like finance, healthcare, law, where an LLM powering it would require to have a deep understanding of this domain. The set of capabilities across these scenarios and domains are widely varied, and excelling at them requires us to be able to adapt an enterprise-grade LLM like Arctic for these scenarios. Our ongoing effort focuses on building the necessary system infrastructure and pipelines needed for this adaptation. Customizing a large language model can involve fine-tuning over a short token horizon when the task is simple, or continued training over a long token horizon, or even pre-training the model over domain-specific data when the domain is really large. To support this scenario-specific training, we've extended our training pipeline to support features like long sequence training, or non-causal attention masks that are common in fine-tuning of the model, but that goes beyond pre-training. Another big component to scenario-specific training is data. In order to enable this, we've built powerful data curation pipelines that allows us to do web-scale data classification to produce data needed for different domains, as well as provides a scalable infrastructure for doing synthetic data generation so that you can create data sets that are hard to find. With this flexible and powerful training pipeline and data curation pipelines, we can adapt models like Arctic to a wide range of scenarios. Here we'll use Cortex Search as an example. Cortex Search offers a deep search experience using retrieval augmented generation. When a user types in a query, the Cortex Search will pull out relevant documents. Then it will compose those relevant documents along with the query into a single prompt. And then the large language model powering it would take that prompt and generate a response based on the context. In order to excel at Cortex Search, the large language model powering it must be able to identify relevant information that is scattered throughout the prompt and then compose that into a meaningful response based on user's intent that is grounded in the context. This requires the large language model to have two distinct capabilities. The first one is it needs to be able to support memory-intensive long context produced by combining multiple docs returned by the retrieval system. And second, the model needs to be really good at multi-needle in haystack capabilities. As mentioned before, the information required to make the response can be scattered throughout the document with thousands of tokens in between that are not relevant. The model must be able to pick out these needles to compose the answer. Building these capabilities requires long sequence fine-tuning with multi-needle in a haystack dataset. First, our flexible training system supports sequences that are hundreds of thousands of tokens long, easily adapting and providing the system support to overcome the challenges of the memory problems related to long sequence training. However, we don't have enough multi-needle in haystack data to train this model, so we generate our own. We use our flexible data curation pipeline to generate this data, and with the fine-tuning of the model, we were able to improve the quality of the model from 34% to nearly 70% in our internal baseline metrics. Now, adapting Arctic to Cortex Search is just a start. There are many other domains like finance, healthcare, law, each with their own specific needs. For instance, financial professionals could benefit from an AI copilot that can help them conduct well-cited, accurate market research, answer CFA questions, or analyze proprietary data and interact with financial reports using just natural language. Our aspiration and commitment is to allow our customers to build fully customizable AI solutions for their domain and scenarios. In order to do this, it's a two-step process. First, we can train domain-customized LLMs by either adapting Arctic or by pre-training a model from scratch on customer-specific datasets. Once you have this domain-customized LLM, now you can integrate this with different toolings and functionalities to create your custom AI solutions like your finance search or your finance copilot. Now we're almost at the end of the talk, but I want to go back to the beginning where we shared that our customers want custom AI solutions that is trusted and secure. We built Arctic with that in mind. Arctic is built with open cookbooks and data recipes that we have open sourced. This gives our customers a clear understanding of what went inside Arctic, and they know exactly what type of data was used to train Arctic. In addition, you can adapt Arctic for your customer-specific domains using the flexible training systems and pipeline that we've developed without the customer data ever leaving Snowflake. By doing this, this is how we create enterprise intelligence that is trusted and secure. We're at the end of the talk. If you guys are interested in building your own custom AI solutions, please reach out to us. We would also love for you to try Arctic. It is available on Snowflake Cortex as well as through multiple major platforms. Thank you.